Before we go too much further with exponential functions, it may be worthwhile just having a look and see what they look like graphically. So if we've got y equals ab to the power of x, and we've got both a and b are constants, so they're just numbers, so our independent variable is x, our dependent variable is y. We have a couple of scenarios here. If b is greater than 1, what does the graph look like? They're very different if b is greater than 1, b less than 1. If b is greater than 1, we can draw our x and our y axes, and we say, right, a crucial point is where it cuts the y-axis, and where it cuts the y-axis is when x is equal to 0. If we put x equals 0, any base raised to the power of 0 is 1, so it'll just go through the point A. And if b is greater than 1, just think of, say, a number 2. When we raise 2 to the power of 3, we get 8, 2 to the power of 4, 16, 2 to the power of 5 is 32, etc. The number is, the y value is increasing at a great rate. So it's not going to be a straight line, but it is going to be quite a steep curve going up. What happens over here? X is negative everywhere over here. So to a negative power is 1 over to the positive power. So what's going to happen is that this is going to get closer and closer to 0. So it's going to keep coming along and flatten out, so it'll get very, very close to 0. So the graph goes on indefinitely in both directions. If a is equal to 1, so you just have b to the x, it'll go through the point 1 there, y equals 1. Okay, that's b greater than 1, b less than 1. So we've got like a fraction here, so you've got to think about what's going on when we've got a fraction. If x is equal to 0, we've got, even if this is a fraction raised to the power of 0 is 1, so it'll still go through the point A, 0A. Now, as x gets larger, you think of like a half to the power of 2 is a quarter, half to the power of 3 is 1/8. So we're getting smaller and smaller and smaller, so we're getting down here. So the graph is going to look a little bit like this. Now because b is less than 1, here we have negative powers. So we've got like a half to the negative 2. A half to the negative 2 will be like 2 to the power of 2, which is 4. So it is going to get steeper and steeper and steeper. So two different scenarios here. B is greater than 1, B is less than 1. If B is equal to 1, which is the only thing we haven't considered there, you just get y equals a, which is a straight line. Won't be an exponential function though. Okay, so just finish with a little practical application of exponential functions. If you had $1,000 invested at 10% per annum, the amount you would have, this is compounded yearly, after 1 year is equal to, now you could find 10%, and then you'd get 100 and add it on, and you'd get $1,100. Another way to add 10% on is simply to, rather than find 10% and add it on, is just to add it to 100%. So 10% plus 100% is 110%, and that is 1.1 as a decimal. So 110% is 1.1. So that would be the amount you would have after 1 year. After 2 years, you would have 100 1,000 times 1.1, that's how much you've got after 1 year. And then you would times another 1.1 because it's compounding, and that'd be after 2 years, which is equal to 1,000 times 1.1 squared. 3 years is equal to 1,000 times 1.1 to the power of 3. And you can see the connection, 2 years to the power of 2, 3 years to the power of 3, after n years equals 1,000 times 1.1 to the power of n. That's an exponential function. Here's my a, here's my b, and here's my x. So the amount after n years is 1,001.1 to the power of n.